Hello, Miss Streisner here, and yesterday we did sample spaces. Today we're going to do simple events. Go ahead and open your table of contents. Let's turn to the page where it has sample spaces, and right below that we're going to do page 36. Okay. We are not going to write probability again because that's just assumed that we're continuing with probability. Right below sample space, we're going to write simple events. Okay? All right, flip over to page 36. Page 36, and we're going to do simple events. Okay, I am going to be using a few colors for this because we're going to have to show some dice and stuff. You're not required to do it, but if you want your notes to look nice and follow mine, you can. I'm just letting you know that I'm going to be using a few colors for today. All right, so we need to define a couple of things about theoretical and experimental events. All right, and I need to get my stuff ready because we're going to do a couple of activities on this. Let me see what color shows up the best on here. Actually, that orange shows up pretty good. Okay. So we have two words that we need to define. We have theoretical and experimental. We need to define them too. Define both of them. So the first one I always like to define is theoretical. And I'm going to go ahead and underline this because we're doing a definition, so I like that to be nice and clear. Theoretical. Now, theoretical is what should, make sure you write should all in capital. Okay, it's what should happen. What that means is if I rolled a dice, I should land on each number if I rolled it 6 times. Theoretically, that's what should happen because each side has an even amount. Okay, so rolling a dice. Oops, that word should be landing. Hang on, let me grab my whiteout. So rolling a dice and landing on 3 once for every 6th roll. Okay? And what that means is 1 out of every 6th is the fraction that it should be. 1 out of every 6 should be a 3. And that's because there's 1 3 out of all of the sides. Okay. Now, experimental experimental is what actually happens. Okay, so we're going to test this theory out. Our theoretical, we're going to see if it's what actually happens. So this is when you do the actual experiment, or rolling the dice, spinning the spinner. What's another one? I can't think off the top of my head, but the actual event that we're trying to take place. Sometimes it's drawing a marble out of a bag, okay? So we're going to write down our rolls. And all of the rolls you could possibly do is 1, 2, 3, 4, 5, and 6. Okay, we're going to draw lines down each one of them. Notice I'm stopping my pen at the same spot each way, just to make your notes nice and neat. You don't have to, but if you're wanting nice and neat notes, that's fine. Okay, and then I'm going to draw my line across here too, and then that ends it. And then here we're going to write our results. I stay nice and neat and I didn't write enough room for my results, so hang on. Results. Okay, so for our results, I'm going to write it in red pen. So we're going to roll the dice, and our first roll is a 4. Okay, our next roll is a 5. So what we're hoping to get is a 3. That's what we're wanting to get. So far we have not gotten a 3. We've gotten a 4, we've gotten a 5. Let's roll it again. Our next roll is a 2. Our next roll is a 1. So far, we've actually gotten each number. Our theoretical is going, so that means out of all these ones, our last one should be either a 3 or a 6. Now, in all my years of teaching, that's never happened. Usually, for some reason, I always roll the same number over and over again. And there we go. There's a 1 again. Okay, let's see. And a 4 again. What numbers did we not roll? We did not roll a 3, which was the one that should have happened. And we did not roll a 6, which should have technically happened. We didn't get either one of those. So, our favorable outcome, what we were going for. So that's a new definition word. Favorable outcome was 3. Okay? Out of all possible outcomes. How many possible outcomes are there on the dice? 6. Let's write our fraction here. So we rolled it a total of 6 times. So remember, at the bottom of your fraction is your all. We rolled the dice 6 times. Out of those 6, how many times did our favorable outcome occur? 0. And that's how you know the difference between theoretical and experimental. Theoretically, after rolling it 6 times, we should have landed on a 3 at least once. Did that actually happen? No. However, when it comes to probability, the more times you do it, the more likely you're going to get that kind of result. So it's a matter of time that it'll happen. So if I kept rolling it, there's my 6 right there. And if I rolled it like 50 times, I would eventually get a 3 multiple times. I just got 5 twice. Let's see. We got 4, 4 again, 1, 1, 4 again, 6 again, 1. Somewhere on here is going to be a 3. There we go. There's our 3. We did this at 50 times, 100 times. We'd eventually even out because the sides are evened out. Okay. Now we're going to talk about a spinner. So what I want you to do is I want you to make a circle right here. Okay? And in this circle, I want you to break it up into 4 places. Okay. One section is going to be red. One section is going to be green. One section is going to be blue. And one section is going to be yellow. I'm going to try the pen, but if the pen doesn't show up, I will use Yellow is just a really hard color to make show up. So let me see if that helps it. See, but this is more mustard than yellow, but that works on the screen. Okay. So when we have spinners, let's pretend that that's my spinner right there. When we have a spinner and you flick it and it spins around and it lands on a color, okay? When you're going to see word problems, and you will on tonight's homework, when we're talking words, so on the side where the red line is, I'm writing words. You might hear words like one out of 4. That out of is very, very important in probability. And I'm going to show you why. Let's finish our sentence though. 1 out of 4 spins are red. Again, that's a theoretical thing. It may or may not happen, but that's the words that you will see. When you see that out of and 1 out of 4, you need to know how to write that as a fraction. Fractions are huge when it comes to probability. So as a fraction, what that means is the number of red out of all. That 4 is all, spins, out of all. There's 4 sections. Okay? So the red, how many reds are on the spinner? Only 1. So 1 divided by all, 4. 1 out of 4 is written as a fraction as 1/4. 6 out of 12 would be 6 over 12. That out of is very important. So just know that that is how you write that as a fraction. Okay? The red would be on top. If it was blue, you would have, still done 1. Okay. Now, here's how you'll see it in a question. So here's how you'll see it in a question. And let me try to write that word a little bit better. Sorry about that. How many So it's asking us how many times should the spinner land on red out of 50 spins. And the way that we solve this is that beautiful thing that we've been doing this entire school year. Proportions. Okay. So the way that we do it is we first set up our proportions. Because it's asking us about red, that's what we're going to focus on. It could have asked us about blue, it could have asked us about yellow. But when it's a simple event, we just take it like it is. So it's talking about red, and there's our word, out of all. Okay? Now in it, it would have either have had this or it would have had the picture. So 1 out of 4 are red. Set up the other side of your proportion. 50 spins. That means each time it's spun, it could have been everything. So that 50 is also all. And then we have our X. Okay? What is it? 13.5 times 4 is 50? I don't really know. Let's do 50 divided by 4, which I don't think comes out. Oh, it's 12 times 5. Or 12.5. So if you're going to do your answer, X equals 12.5 spins. Okay, that's it for the lesson. Lots of fun things. We got to play with dice. We got to play with spinners. You know, in class we'll probably do some kinds of activities about this and stuff, but for your homework, these are the key words that you need to know to be able to do this. Okay, so good luck. Let's work a couple of problems together.